Hi everyone, and welcome to the second video in our WCRL Getting Started series, The Design Guide. I'm Sam, and in this video we'll cover CAD software, design tools, and good design practices. In addition to this video, we also have the Getting Started video, Electronics and Coding with Arduino guide, and 3D Printing and Assembly guide. We plan on adding more videos, such as a guide for using the Raspberry Pi Pico in the future. We recommend watching the whole series before you start your bot. We showed this slide in our last video, but we wanted to remind you to be unique with your design and try to improve on some of the common bot designs that you see here. Before you start designing, brainstorm with your team to come up with an idea of what you want your bot to be. There are lots of different computer-aided design or CAD softwares out there that you could use to create a 3D model of your bot. WCRL recommends using Autodesk Fusion 360 for a few reasons. First, there is a free student license available, so you don't need to get a license through the school. It is also cloud-based, meaning you can access your files anywhere by logging into your account. On top of this, it's a pretty capable 3D modeling software that has everything you need to make a detailed model of your bot. Tinkercad is a web-based CAD program that is also free to use, but it is much less powerful than Fusion 360. SolidWorks and Creo are two of the more professional CAD softwares out there, and many Watson students might have a license from the school. These programs are also good for modeling your bot, but your school license doesn't last forever, and you will lose lots of model data when transferring to another software. So we recommend starting with Fusion 360 so you can always access and edit your CAD models. This video will not be a guide on how to use CAD software, as that is taught by the EDD program already, but we will link to some good tutorials if you're a beginner in the description. You can also stop by a Build Technician's office hours to get help with CAD. There are a few design tools that are essential to use when designing your bot. For example, let's say you have a motor that you want to add into your 3D design. You should first check the GrabCAD library, which is a huge online library of CAD files. Most common parts like N20 motors and Arduinos will be available to download for free to add into your CAD assembly. If you can't find a file on GrabCAD, taking measurements with calipers will allow you to design the part yourself to fit into your model. WCRL also has reference bots on display in the Fab Lab for you to look at parts and help you with your design. Now, let's go over what size your bot should be. WCRL bots have a 1 kilogram weight limit, but no size limit. This bot here is an example of a small bot. It's 17.5 by 17.5 by 4 centimeters. Next, we have more of a medium-sized bot, measuring in at 21 by 20.5 by 5 centimeters. This bot is on the bigger side. It's 34 by 19 by 5.5 centimeters. Smaller bots have the advantage of being a harder target to hit and being more nimble. It is more difficult to fit all the electronics inside. As we'll talk about later, this means it's very important to model everything that's going inside your bot, so that you can be sure everything will fit. With bigger bots, you'll have more space to fit everything, and you might be able to fit a larger competition attachment, but you'll have to watch your weight more closely. Different designs will call for different bot sizes, but you can use these bots as a reference for your own. One important way of thinking when designing your bot is to design with assembly in mind. In this old bot that I made, I have this drive motor, which I was going to put through here, and have this wheel that was going to fit in this slot. I was going to secure down the motor with 2 screws on this face. However, I didn't design with assembly in mind, and so if I put the motor through, I can't fit the wheel in. If I put the wheel in first and then the motor, I would not be able to reach these 2 screws. This goes to show that it is important to think about how you're actually going to put the robot together during your design process so that you can avoid mistakes like these. Let's switch over to Fusion 360 to talk about some more good design practices. First, it's important to model as many things as possible that are going in your bot. Besides all the 3D printing components, you should include all the electronic components that you're going to use. If you don't do this, you have a higher chance of running out of space for everything and having to make major design changes to your bot after you print it. Some components, like this Arduino, you can download off of GrabCAD for free. Other components, like this battery, I just use a simple shape to model because all we really care about are the outside dimensions. If you're using the WCRL provided battery, the dimensions are 68 by 35.5 by 25.5 millimeters. The WCRL board's dimensions are 69 by 40.5 by 10 millimeters high at the Arduino connector. For a full list of all the electronic components you need, see our electronics and coding video. Next, when you start out, I recommend starting by designing the chassis. Before you start designing, you should have an idea of what your bot is going to be, what kind of drive system it will have, and what kind of competition attachment you will use. By designing the chassis first, you'll be able to see what kind of space constraints you have and figure out how to mount everything. After making the chassis, I then like to design the drive system and the weapon. For wheels, you can either 3D print your own or purchase some online. Competition attachments must be 3D printed. Also, each individual part should be its own part file. You should combine all the parts together in an assembly. This helps you stay organized, makes it much easier to export different parts individually to get 3D printed, and is the professional way of designing an assembly. Also, don't forget about including mounting for a kill switch and for an LED. For some components, like the WCRL board, you might not need to design a rigid mounting support for. Providing enough space for the component and securing it down with Velcro or tape, you should not have a problem with it moving around. Another thing to go over is holes. For 3D printed components, tapping threads with the screw itself may work initially, but it will wear out quickly. For example, for this wedge, I have 4 screws that secure it to the chassis. Some high-end printers and materials can directly print threads, but it is not recommended for WCRL materials. Instead, you should design to use threaded inserts, which are small brass pieces that you can install in your printed piece that give you a metal thread for a screw. WCRL commonly uses heat set inserts, which use heat from a soldering iron or similar tool to melt into a hole in the plastic and lock itself in. So let's say you want to secure this wedge to the chassis with M4 screws. I would look up the recommended hole size for M4 heat set threaded inserts and size the holes in the chassis accordingly. Then, when I'm going to assemble my bot, I would put in the 4 threaded inserts into the chassis and would be able to screw down the wedge into it. Remember that the design process is continuous. You'll have to revise your design multiple times throughout the semester as you discover things that need fixing or improvement. If you have any questions, please contact WCRL at binghamton.edu. Thanks for watching.